Steps 1 through 4. Draw, divide, calculate, combine. Right? Draw, divide, calculate, combine. It's really simple. Let's have a go at this example. Here's this kind of upside down looking L shape. Okay? I don't, sorry. By the way, this is one of the reasons why if you're drawing your diagrams, please pick up a pencil. If there's something else, maybe just put a clean line through it, and then it's okay. It can be close enough, as long as it has all the important pieces. Okay. So please, with me, just like I have, I've already done the first step with this upside down, turned around L shape. Okay. But I'd love you to draw it with me. Okay. It's not a complicated shape. You should use your ruler so that it does look reasonably accurate, and it's not like got wavy edges or anything like that. The first thing we're going to do is draw it. Now, drawing is not just useful so that you can see something and understand it, but we can't do any of these other steps without a drawing. You can try and do it in your head, but you're kind of setting yourself up to really have difficulty. Okay? So, this is a composite shape. It's not a rectangle, it's not a square, it's not a parallelogram, but we can think of it as made up of other kinds of shapes if we combine it in the right way. Okay. So, for instance, I'll turn it back on a bit later if it's okay. Okay, yeah, a lot of people are warm, including me. Let's think about how we can divide up this shape. Okay, there's lots of different ways. Here's one. Having finished drawing this shape, okay, if you got another color, that would be handy, but it's not compulsory. I'm going to divide this up right down here, and I'm going to put this in another color in dotted lines. Okay. So now, if I divide up, this is my second step, right? If I've divided up this shape, now lo and behold, I have 1, 2 rectangles. Can you see that? And I can work out each of the rectangles on their own. That's sweet, right? I've got formulas for those, okay? But before I can do that, I've drawn it, I've divided it. Because I put in this new line, I need to label something that's missing, okay? Firstly, I've got 2 rectangles. I don't want to confuse them with each other. So I'm going to call this one rectangle 1. And I'll call this other one over here rectangle 2. That's just so I can distinguish between them, okay? Rectangle 1, as we're about to do, I can work out its area, no problem, right? I have its breadth over here, I have its length, so far so good. But when I look at rectangle 2, I'm missing something, right? I have a length, but I don't have a breadth, right? What can I do to work this out? Yeah, Daniel.
You get like the top one, so 20.
Yep.
And then the one on the bottom, so 8. So
yep.
20 from 8.
Yeah, very good. It's going to be the difference between those two. It's 12, right? Very good. And lots of you spotted that. Fantastic. So that's a really important kind of distance to have on there. And you use the information given to you on the diagram to work out the bits that you need to label. Okay? So what I've done here is I've labeled not just the different areas. I've labeled the different areas that I got. And I also labeled any missing lengths that I need to do the next step. Okay? So we've done step 1, we drew it. We've done step 2, we've divided it up. Now into step 3, we want to calculate. There are 2 pieces and we'll just calculate them one at a time. So we've got the area of the first rectangle, and it's just length times breadth. That's 15 times 8. 15 times 8. Okay, now we could reach for our calculators here, but I think we can do without them. 8 times 10 is just 80. And then 8 times 5 is half of that. It's 40. So it's just going to be 120. By the way, this is an area. We looked at units before. What area unit is it? Yeah, Nathan. Centimeters squared. Very good, right? So in some ways you can kind of see it because this 15 is actually 15 centimeters, right? So there's centimeters there. And this 8 is actually 8 centimeters. So look, there's centimeters times centimeters, hence centimeters squared. That was the first rectangle. Let's just do the second one. Okay, so we've already got the dimensions up here. It's going to be 7 by 12, or 7 centimeters by 12 centimeters. Who's good with their 7 times table? It's 84. Very good. on the boulder point. Well done. 84 centimeters squared. So now we're done with those calculations. We drew it, we divided it up, we calculated all the parts we divided. Now is the last step, combine it. So I tend to write down here, total area. That's how I know, because I've got all these equations flying around, now I know which one's which. The total area is this plus this. So let's write it down and then you can give me an answer. 120 plus 84. Okay, Jordan.
200.
Fantastic. Well done. 204 centimeters squared. Full stop. Okay? So, well done. We went through the 4 steps and they kind of just went like that, really. We drew it, we divided, we calculated, and then we combined. Now, just one little quick note before we end. Okay? You'll notice I say combined, and I didn't just say add them up. We did add them up this time, but sometimes combining means subtracting. So, you don't have to draw this with me, but actually, I'll ask you to put your pens down, just so you can see this really quickly. I'm going to replay this super fast. Just put your pens down, because I don't want you to worry about writing this out. I just want you to see that it's another way of doing this. I've got all my same dimensions here, right? And we divided it up by putting a line down here. Okay. Can you see? I could have divided it another way, couldn't I? Yeah, what's another way? Yeah, Ethan.
There's 2 more ways you could have done it. You could
Yep.
have gone across.
Yep.
And then, or you could have gone across and up and made it 3 squares.
Yeah, very
No,
good. Or 3
squares.
Three
No,
rectangles.
3 rectangles.
Yeah,
that
good.
look like squares.
Okay, so let me say that first thing, right? I could have gone across here, and it would have still made 2 rectangles, but there'd be other rectangles, wouldn't they? Okay. Not only that, I could do both. I could divide it like that. I wouldn't do that though. Can anyone give me a suggestion as why I probably wouldn't? Yeah, Will.
Because there will be strategy where you do 20 times 15, so pretend it's an entire square.
Oh,
And then
wait,
just
you're getting
minus
onto,
that-
you're gonna, yeah, okay, I'm gonna get to yours in a second, Will. That's actually why I drew this new one. Nathan, do you want to suggest why would I maybe not do both of these divisions?
Takes longer.
Yeah, it's just like, I'm just kind of needlessly making work for myself. It's like I could do it in 2 rectangles. Why do it in 3, right? Okay, now, let me get on to what Will was mentioning.
Oh, so.
Okay.
It's only on 5% battery.
It'll be fine. It'll survive. Okay, now this is what Will was saying, right? Can you see, I can think of this as 2 rectangles added together, but I can also think of it as 2 rectangles, one taken away from another, right? So you don't need to write this down, but you can see I've got a big rectangle here, right? So if I call that, like, I'll literally call it big rectangle, okay? What's the area of the big rectangle? It's 20 by 15, which is, yeah? 300, very good. And then I've got a smaller one here, right? I need both of these lengths. What's this length?
8.
That's going to be 8. And we already worked out the other one is 12, right? So I can say the small rectangle is 96, very good. And so when I do the total, I'm not going to add those. Like, one is being taken away from the other. Does that make sense? So I would go not add, but subtract, which of course is going to give us the same answer as before because it's the same shape. Okay? So what I would advise you to do is don't just like draw the first line that you see. Okay? Look at it carefully. As you draw it out, it will help you see where's the most efficient way, the most quickest path through to work out the area nice and easily.